Hello everyone, welcome back. So today we are going to start with the module 2 important concepts. So you already know from module 2 onwards we have problems. So here mainly we have important is your process state. I think you people are very familiar with this, and PCB. I'm just not writing the question but some of the concepts which are important. Then we have many different important concepts in second module, that is your IPC, that is interprocess communication. Then we have multi-threading models. I'm just writing about these concepts which are many a times asked in the previous questions, and also it's easier to solve and gain complete marks. Then the next again important question is nothing but one problem is there always from this. So they are none other than scheduling algorithm problems. So process scheduling problems we have. So these are the four main concepts in your module 2. So let's start with one by one, and I'm just going to make one separate playlist for only for the problems, uh, because many of them have asked for the problems where we are unable to solve it and all. So I'll definitely go with your problems also. Okay, so let's start with your process state and PCB. This question is asked for nearly 10 marks. Okay, if asked both together. If it is asked for only process state or only PCB, so it will be nearly to 5 to 7 marks again. So it's better to know both the concepts because both are as important and they have asked again and again in many of the question papers. So let's start with the process state. Here in the process state, before this they have most of the time asked for the definition of process and or say definition of thread also. So you should know the basics of process and thread. So let me define what is process now. Your process is nothing but a program in an execution. So this is your definition for your process. Now, when I say a program in execution, say your program is nothing but whatever C program you write, and then you start click on a run button, then it starts running. That's what execution. So that turns from the process, I mean program, to the process. So programs are basically in your secondary memory. So when they start executing, or when we are trying to execute those programs, they are loaded into your main memory. So that program which is called there in the secondary memory, and we are loading it into your main memory. So when that program comes to main memory, it starts its execution. That time it becomes process. So in general, we can say that a program is nothing but a passive entity that is stored on a disk, whereas a process is an active entity, because a program becomes a process when an executable file is loaded into the memory. So this is how your process can be defined. So you can just write one line here: a program in execution is said to be a process. Now coming to your definition of thread. Thread is nothing but a part of a process. Like say, if this is a process, we can have many threads here. So we can have n number of threads for one process. It can be any number of threads there. So now what is a thread? In simple definition, it is a unit of execution within a process. So a process can have anywhere from just one thread to many threads. So I hope your thread definition is also clear. Say for an example, I'll just give an example for you. Say suppose you have a WordPad, and your task or the process is to type. I mean, you are going to type something on the WordPad. So the task or the process is typing the words. And meanwhile, while you are typing, it will do the spell check. If you remember, or if you have done any time, it will give you a red mark or a blue mark like that while you are typing. So that internal checking, or that checking of spellings, is another part that is being done internally. So that another part is nothing but your thread. So your spell check is a thread, and typing of the word is, I mean, the letters or the paragraph is a process. So that is how you can define, or to understand better, this example I have been given you. Now, going to the next, that is your process state. Now, when I say process state, first you have to define what is process state. Now, when I say a process state, it's nothing but a process executes if it changes its state. Say a state of a process is defined in the part by the current activity of that process. So like, say suppose now process is executing. At that time of the execution, maybe it got some interrupt, it got to use some input output devices and all. So that process which was in the running, it will go to some other state. So here we have a important diagram for your process state. So this is how your diagram looks for your process state. To write for process state, first you have to define all 5 states. So to remember which are the states, usually students say this, they don't remember how to name these states. So again, here I will be giving you all one example so you can remember the states here. So new, ready, waiting, running, and terminate state. Now, before going to this, I'll just give you all one small example. Say you people now have taken the admission, you are new, okay? Then when you took an admission, everything is done and you are ready to write the exams, correct? So to write the exams, we have to fill the exam form, fine? When you fill the exam form, we give you a hall ticket. That means now you are ready to write the exam. So we keep you here, that few students are eligible, few students are not eligible, like that. So now you are ready to write the exam. So when you get an exam date and you are being given the hall ticket and you start writing the exam, that means this scheduler is none other than us, who are providing you people the hall tickets. Like your faculties or your office staff might provide you the hall ticket. So that time they will send you to write the exam. That means you are eligible to write the exam. Now you were ready to write the exam, so you started writing the exam. That is a running state. You are in the execution. Now when you are in the writing, that is you're writing the exam. Here when I am writing the exam, I can have a 3 scenarios. Like I can say 3 different cases can come out here. How is that, or how can I think about this case is nothing but, like say, while I was writing an exam, I didn't get any interrupt nor any difference, I mean anything. Then I wrote all the exams. At the end, I got my results. I have been terminated. In the sense, I have come out of that particular semester. I'm done with that particular semester. So I'll be terminated. That means I'll exit from that semester and I'll go to the next semester. Now, if in case you wrote the exam, but still you were unable to clear that exam, so you failed in that exam. Now when you failed, that failing is nothing but kind of an interrupt. You got a result saying that you failed, so that was an interrupt for you to terminate, correct? You couldn't terminate, right? You cannot go. Okay, there is some criteria there, but in this situation I'm telling you, so you failed, that became an interrupt now. So again, to write, you have to rewrite the exam so that you can come out of that semesters. So again you will be filling the form, then you will be ready or eligible to write the exam, and the hall ticket will be given and you start writing the exam. Now after some time, or you have written again the exam, or maybe while writing first time only you have written everything but you couldn't get the result. Maybe sometimes you might have seen in your results sheet that withheld, sometimes you might have got the results. So that withheld is maybe due to some technical things or some uploading things of the marks might have arisen. So some event might have occurred where it is making your results to wait. So that is making you in the waiting state. So once they have cleared with that error, they have seen that they inform the office people or your any college people that yes, they are cleared it, and they can need not write the exam, but you can just terminate them. Or if they say you have to wait till the result comes, so your results are withheld and it's everything done, and again you will be shown that yes, there is no need of writing, then you can completely execute, but you have to come to the exam hall right here. That is how the situation becomes here. Okay, and then you are being terminated. So this is one small example I have given you. So now to explain about this, first you have to define these states. I said new state, you are new, you are ready, you are running, you are waiting, and you are terminating. Simple scenario, you understand, so you can define. So new state can be defined as the process that is being created will be in a new state, the definition for new. Then the definition for the ready can be the process is waiting to be assigned to the processor, that is assigned to running. Okay, so that can be defined in your ready state. Now coming to your waiting state, or we'll first define running state so that you can understand the waiting. Running, you are just going to define as the instructions are being executed, that is which instructions, the processes instructions are now being executed. Now when I say the processes are in the ready state, they are already in your main memory. Now from the main memory they should be given to the CPU, right? So that CPU starts its execution. So from the main memory, now from the main memory, so the processes from your main memory which is already ready for the execution will be given to the CPU. So that time the processes go into your running state. Now when the processes are in the running state, you have three cases. You can see here three arrow marks are going on out. So you have three cases to be seen here. So before going to that, first I will be defining waiting and terminate, then we'll go with these three cases. Now when how I can define the waiting state is the processes that are waiting for some event to occur, or if they need any input output services to execute, then the process which was in the execution, now maybe it is running, some process is running, meanwhile while it was running it was in need of some input. So that input can be given from your input devices only, no? So it will come out, then it will go into your waiting state. So when it is in the waiting state, meanwhile it will get some input output devices, then it will complete what it has to or what it needs, then again it will go back into your ready state. Okay, so it will stand in the queue again. So here will be the ready queue for the processes. Then again as its turn comes, the scheduler will dispatch the process to the running, that means for the execution. That time it will again go for the running state. Now coming to your terminate state, how I can define is the process that has finished its execution, that means it has completed everything with the execution, it can be terminated. Obviously we have to terminate the process, else your memory will be full. So no memory is released, then I cannot execute any other processes. Now first thing what you have to write for the process state is your definition for the process state, then definition of all five states, then your diagram. So see, first point is your definition, second, third, fourth, fifth, sixth point about the definitions of the states. And this diagram is very important. Please don't even change the arrow marks. So it's very important how you draw this diagram. For that reason, I'm explaining with the diagram so that you people remember the diagram, or you people remember the concept. Now, I had told you all, while the process was in the running state, it might get three different scenarios or three different cases. Okay, as I told you all in the example, that while you were writing the exam, okay, maybe there was no any issue with the exam, you have written it, you have cleared it, you have terminated. So that case is the first case. So according to your, or in terms of the process, how it will be, it is like, see, when processes are in execution, now they are in the ready state, they are into execution, they come to your running state, they had no interrupt, they required no input output, or there were no any event that had occurred, so they just normally executed. So they have done with the execution, they will terminate. So that is your first case. This is coming out. Now your second case is, now maybe while your process or the process is running, okay, it gets some interrupt. Like interrupts can be your software interrupt or hardware interrupt, anything like that, as I had discussed. Okay, now to execute that interrupt, I have to clear with that interrupt, right? So maybe your process or has something to do with divisions. Now division, like divide by 0, that is like a software interrupt, that is an exception. So that interrupt should be cleared. Now you write the exception cases and you try to catch that exception, so that interrupt will be held. Same way, if the process is getting any interrupt, it will be executed and it is again kept back into the ready queue. So the processes which are there in the ready queue, they will be continuously in the execution state, and the next process which has executed the interrupt and it is in the ready state, now maybe it is ready to be going back to the execution state. So again the scheduler will dispatch and it will execute. Same way, so this becomes your second case. Now third case is, maybe while it was executing, it was in need of some input output devices to be completed with the execution. So it will use some input output devices, or maybe some event might have occurred in between, like that. So any of the situations can be arised here. So while it was in need of input output devices, the process or the user does not have a direct access to the hardware, that is the user. So for that reason, the OS will be interacting with the hardware. So that time, the process which were in the CPU will make it to wait. Now while this process is waiting, there are some other processes here in the ready queue that will be running, but the current process which was running and it got an input output, it was in need of some input output devices, it will go into the waiting state. So it will be waiting here until it gets those devices. Once it gets its devices, it will complete its execution of what it was in need, and again it will be kept back into your ready queue. So that time again, when its turn come, okay, that process, then again the scheduler will dispatch from the ready queue to your running state, where the process starts execution. That means the processes will be executed, then completed and terminated. So all these three cases are very important. So whenever there is a process state being asked, please do write the definitions of all 5 states along with these 3 cases and the definition of process state and the diagram. I hope this makes very clear for your process state. So next we have is your process control block. So process control block, in a simple way I have to tell you, is it's nothing but it's like your office, in your college office. The block that administrative block, it has all your details, correct, in your office. Whatever is your USN, or whatever is your PAN number, Aadhaar number, or whatever, you are from which place. Okay, everything about your details will be held in your or it will be recorded in your office. The same way here for your process control block, we have all the details been recorded, or all the details regarding the process can be found in this block. Now these blocks are separated, I mean it is separately maintained for each process. So this is very important to be known, that for each process there will be a PCB. So I hope now you all are clear with what is exactly the PCB. So it's usually asked along with the process state only, or sometimes asked separately, very rarely. So when you have to know about your process control block, this diagram is again very important. So as I said, it will be holding all the informations regarding the process. So you should know about what process ID, the process number, the state of the process, the program. I'll be explaining what exactly it is. Now process ID and process number are again a unique number. As I said, your USN and your Aadhaar card. Okay, like that your process ID and process number are. Now process state, now just now we have seen what states can the processes be in, like a new state or a ready state or a running state. Okay, so that it will be defined here in the block. Now coming to your program counter. Now what is this program counter? It's nothing but it will hold the address of the instructions, or the next instruction that needs to be executed. Say suppose there is a program here, and the program is always executed line by line, correct? So this line is now executed. Now I have to execute this next line, so says 1 and 2. Now I have to execute second line. So this address will be stored here in the program counter. That means the program counter will hold the address of the next instruction that needs to be executed. So other than that, we have a registers. So here registers are nothing but they are being like particularly for the process. So it can be index registers, your stack pointers, or general purpose registers, and so on. Okay, along with this you also have to explain about scheduling also. Though here they have not given, you should explain about the scheduling also after the registers. Now when I say scheduling, it's nothing but which process will be scheduled first for the execution, which is the next process that needs to be executed, like that this all information will be holding. Now when I say CPU scheduling, it is according to, or it is based on the algorithm, that is scheduling algorithm, which you will see in the later part. Okay, so it will determine which process should be scheduled. So that scheduling or that timetable, according to how much time this process have to be executed, and which process should be the next to execute, that is all being handled by your scheduling, that is through your scheduling algorithms. So then next we have memory limits. That's nothing but all about your information about the memory management. That means each process is taking how much part of your memory, and at what time or how much long it is using that part of memory, and after using how much part of your memory is released. So all these information is in your memory limits. Now coming to the next, we have one more that you have to remember is your accounting, which we saw like in your operating system services. Accounting is again nothing but how much resources, it's like in general which resources the processes are using. Okay, like that all particular details or the records of how much the processes were used from by which process, how long it was using that process, how much did it use, that all recording will be kept in your accounting. And input output status, it's like input output devices are also being used sometimes, as I said in your process state, that it may need some input output devices to be executed, correct? So that all status are being assigned to a particular process for its execution. So that all status, how many files it is open, how many it is being closed, that all will be recorded in your process control block. So this, in exam, if it is asked, you're just going to define all among these along with these two, along with the CPU scheduling and the accounting. Then you are uh, supposed to gain complete 10 marks. So one thing you'll have to remember is the diagram. So this diagram and your process state diagram is also very important. If you understand the concept and you know the diagram, you can write it on your own also. So that's the reason I have given you all one small example regarding your own engineering journey. So please, I hope it's very important, because it's completely known to, I mean, completely many are times asked in almost all the question papers. So that's the reason I have covered this concept. So I hope it's clear. Thank you so much. Please do share and subscribe the videos for the more videos. Thank you.